Alright, on our last day of section 4, or 5.4, we are going to be working with ease and integration. And so what we're going to learn today is the integral of e to the x happens to be e to the x plus c. And this is for an indefinite integral. For definite integrals, as we know, we do not put the plus c on the end. And the integral for e to the u, so something more complicated than just an x, we're going to say is e to the u plus c. So we'll be making some u statements to help us be able to integrate. This first problem, this happens to be a more complicated integral, so we'll go ahead and make a u statement. I'm going to choose my u to be my exponent, negative x to the fourth. This one works out nice and neat because when I take the derivative, I get negative 4x to the third dx. That is exactly what I needed. When I rewrite this integral, then I have e to the u, so that takes care of this part right here. And then I need exactly this part right here, negative 4x cubed dx, and I have that. And so I'll just simply put a du. That means the integral is just e to the u plus c. And so what I need to do is I need to go back and plug in my u value, which is negative x to the fourth. On my next example, you may be questioning what should you pick for your u statement, but remember we're always trying to pick things that will help eliminate other parts, and a good clue is always to try something that's inside parentheses. So we'll go ahead and try that. I have u equals e to the x plus 1. That's what's inside the parentheses right here. So when I take the derivative, I get e to the x dx. Well, that seems to have worked out. So when I take the integral or rewrite this, I have u squared. That takes care of this part right here. And then I need an e to the x dx, and I have that e to the x dx with my du. So now I'll just go ahead and integrate this. So I get u cubed over 3 plus c. And then I'll just simply plug in what my u was equal to, which was e to the x plus 1. And I have my solution. On the next problem, this one again is another u statement. When we have problems like this, a lot of times we want to pick the bottom. But on this particular problem, we're actually going to want to pick the top exponent so we can take the integral of e to the u. So my u is going to be x to the negative second, which is what this exponent is. It's x to the negative second. Du is equal to negative 2x to the negative third dx. So I'm going to go ahead and start to rewrite this. I have e to the u, and now I need an x cubed on the bottom, so really a 1 over x cubed dx. And I actually have that over here. I have a negative 2 over x cubed dx. Now, I do not want this negative 2, I only wanted a 1, so I'm going to divide by negative 2 on both sides, and that puts a negative 1/2 on the other side. And now I can replace my 1 over x cubed dx, this portion, with a negative 1/2 du. Taking the integral, I get negative 1/2 e to the u plus c, and then I'll substitute my u value back in, which was that 1 over x squared. And I'm finished. Alright, we're getting ready to do another integral. On this case, I don't want to pick my u to be 2x because if I do that, the derivative is just 2, and that doesn't help me get rid of the bottom. So I'm going to give it a shot that u is equal to the bottom part, 1 plus e to the 2x. So when I take the derivative of this, I end up getting du is equal to, the derivative of 1 is 0, e to the 2x times 2 dx. So my du is actually equal to 2 e to the 2x dx. So when I start to rewrite this integral here, I have the u on the bottom, And I need just an e to the 2x dx, so just this portion. So what I need to do is I need to solve, and I will do so by dividing by 2 on both sides. That gets me my e to the 2x dx by itself. So I'll go back and I'll rewrite this as 1/2 du, and that takes care of these two portions. So that means I have a 1 on top. Well, we know now that the integral of 1 over u is the ln of the absolute value of u plus c. And then what I'll do is I'll go back and I'll plug in my u value, which was 1 plus e to the 2x. On the next problem, I'm probably going to, just at first glance, I would pick what's inside the parentheses on the bottom. So we'll go with that and see how that goes for us. Taking the derivative of e to the x is e to the x, plus the derivative of e to the negative x is e to the negative x, times negative 1 dx. So I have du is equal to e to the x minus e to the negative x dx. That's not exactly what I needed up here, but what I can do before I start this rewriting process is I can take out a 2. Now you should see that that's exactly what I have here. So really all I need to do is bring that 2 out in front when I go to rewrite this. So I'll bring the 2 out in front. I have on the bottom what it's u squared, so I've taken care of that part. And now I need this e to the x minus e to the negative x dx, and I have that right here. So I'll just go ahead and put du. I'm going to put a 1 on top. So when I integrate this, I'm really integrating u to the negative 2. So I end up getting 2 u to the negative 1 over negative 1 plus c. So that's a negative 2 over u plus c. And I still need to substitute that back in. So I'm going to see if I can squeeze this in here. So I have a negative 2 over u is e to the x plus e to the negative x plus c. My last problem is a definite integral. So I'm going to go ahead and pick my u to be my exponent there, secant 2x. My du ends up being the derivative of secant, which is secant tangent. So I have secant 2x, tangent 2x, and then the derivative of 2x is 2. And I need to put my dx in there, so I'm squeezing that in there. Sorry for that. When I go to put this back in, or rewrite this, I get e to the u, so that takes care of this portion. I need just this part right here. I have that if I move the 1/2 over, so I'll move the 1/2 or the 2 over to make it 1/2. So I have secant 2x tangent 2x dx. That part is equal to 1/2 du. The integral of e to the u is e to the u plus c. Oops, I forgot it was a definite integral. Back here and make substitutions. I need to plug those values in for my secant. I will be finishing this up on the next video because I won't be able to get through it at this point with the time I have left. Alright, let's go back and explain a little bit more about what I was just doing because I was kind of rushing through that because I thought I could get through it, but I can't. So I'm going to go back through and I'm going to erase a few things here just so I can take a step backwards and look at this a little bit more. So I've got u is secant 2x, and then I took the derivative of that. Then I noticed I only needed secant 2x tangent 2x dx, so I had to move my 2 to the other side. So that allowed me to rewrite this as e to the u, and that took care of that portion. And then the 1/2 du was taking care of the rest of this part. Now, I did not change my bounds yet, so I need to do that. So I'm going to use that method where I take and I plug those bounds in, and so I can just change them into u values. So I'm going to have to think about what is the secant of 2 times pi over 2. So I'm really asking myself, what is the secant of pi? Well, secant is 1 over cosine. So the 1 over cosine, or 1 over cosine of pi, the cosine of pi is -1, so I have 1 over -1. So that means that this value for this bound right here is -1, so I'm going to write -1. And then I also have to do it for pi over 3. So pi over 3, when I plug that in, I get secant 2 times pi over 3. So I'm thinking about what is the secant of 2 pi over 3. Or really, I want to think about it in terms of cosine, the cosine of 2 pi over 3. The cosine of 2 pi over 3, well, 2 pi over 3 is 120 degrees right here. All students take calculus, so I know it's going to be a negative answer, and then I need to think about my reference angle. My reference angle is 60 degrees, so the cosine of 60 is 1/2. So 1 divided by -1/2 happens to be a -2. So now I'm ready to take the integral of this. So I'd get 1/2 e to the u, and then I need to plug in my two bounds, my two new bounds. That way I don't have to change them back to x's. And when I do that, I get 1/2 e to the -1 minus e to the -2. And so I could rewrite this if I wanted to as 1 over e minus 1 over e squared. You could also plug it into your calculator to get a decimal.